Today we're going to continue looking at our 3D objects and continue with spheres. So section 10-8, spheres, is what we're going to look at right now. The objective for today is to recognize and define some of the basic properties of spheres, and then to find the total area and volume of a sphere. So here's what a sphere is. There's a definition of a sphere. You can see there all points that are a given distance from a given point, call its center. So the center of this sphere, as you can see in front of you, D is going to be the center. So some of the properties and characteristics of a sphere are very similar to those of a circle. So we're not going to spend a ton of time with some of these and go through them somewhat quickly. So needless to say, pause the video if you want to write something down, or if you need to go back on something, feel free to do that as well. The radius is a segment whose endpoints are at the center and a point on the sphere. So this sphere here has three different radii. dA is one radius, DC is another, and then lastly dB. So those are three different radii of the sphere that's in front of you. A chord, now this is new. A chord, as you can see there, is a segment whose endpoints are on the sphere. So in this sphere here, I have FG. Here's one segment. Here's one segment whose endpoint is on the sphere. Here's another endpoint on the sphere. So FG is also, is a chord. Another chord in this sphere would also be AB, segment AB. One endpoint on the sphere right here by A, another point on the sphere right here at B. So segment AB is also a chord. A diameter. Diameter is a chord that contains the sphere's center point. So diameter is going to go all the way across and go through the center. Looking at our sphere here, one chord, so we named the two chords on the previous slide as FG and AB. Notice in this slide, talking about the diameter, AB goes through the center of the sphere, goes through point D, which is the center, so AB is a diameter. And the only diameter of this chord, or of the sphere that we're looking at. A tangent. Here's a tangent. You can see there it's a line that intersects the sphere in exactly one point. We'll spend more time with tangents when we get into circles, which is the next chapter. So let's just move on from that. When dealing with intersection of a plane and a sphere, you can look at these three examples. We have three options. It's either not going to intersect, so no intersection. It's going to intersect in exactly one spot, right there, or it's going to intersect in a circle. You can see the circle formed right here. So think of this as a plane cutting through, kind of a piece of paper cutting through a tennis ball or something of that nature. A circle is formed because of the shape of the sphere. So we're going to deal with these circle intersections. When a plane intersects, a circle contains the center of the sphere, the intersection is called a great circle. So you can see here the plane in red is intersecting the sphere, and the plane contains the center of the sphere. So this right here, this circle that is formed, is considered a great circle. The key to a great circle is that the radii of this great circle are also the radii of the sphere. Each great circle is going to separate a sphere into two congruent halves. We call those hemispheres. Again, think of like the planet Earth and the northern and southern hemisphere, eastern and western hemisphere, things of that nature. So a hemisphere is just half of a sphere. Here are the formulas for total area and the volume of a sphere. Notice that we don't have a lateral area formula, and this is because there's no lateral area, there are no sides to a sphere. It's just total area. There's no sides at all, so we can't have, we talked about this with the word, within the word, lat means side, therefore there's no side of a sphere by any means. So total area is 4 pi r squared, the volume is 4 pi r cubed, all divided by 3. So hold on to those, we'll deal with those in a second, especially in this first example. So I want to find the total area and volume of a sphere with a radius of 5 centimeters. So again, we have the radius, that's important to us. And as always, we want to leave our answer in terms of pi. So total area, once again from the previous slide, is going to equal 4 pi r squared. Here's our volume formula. Volume equals 4 pi r cubed. all divided by 3. So for this one, radius is 5. Let's plug it in for our total area. Total area equals 4 pi times 5 squared. 5 squared, of course, is 25. Total area equals 4 pi times 25. 4 times 25 is 100. So my total area is 100 pi centimeters squared. Again, area is still centimeters squared. Looking at the volume now. Volume is 4 pi times 5 cubed all over 3. 5 cubed this time is 125. The volume equals 4 pi times 125 all over 3. And when I multiply 4 times 125, I end up getting 500. So on top I have 500 pi. On bottom I still have the 3. 500 is not divisible by 3, so I'm going to leave this as 500 pi over 3 centimeters. Again, we're talking about volume this time, so that's going to be centimeters cubed. Now these next two examples are a little different. They give us the circumference of a great circle. And if we remember back to this previous slide right here, the definition of what a great circle is, a plane that cuts through the center of the sphere and contains the center of the sphere. And also, again, the radii of the great circle are also the radii of the sphere. So let's think about circumference in a second in terms of radius. Way to find circumference is 2 pi times the radius. We're given this circumference right here, 83.92 equals 2 pi times the radius. We are looking for the radius, so we don't do this very often. So we're going to actually use 3.14 for pi. So I'm going to get 83.92 equals 2 times pi. Again, we're estimating pi here, times 3.14 times my radius. 2 times 3.14 is 6.28 times the radius. Divide 83.92 by 6.28. I get my radius ends up being, rounding this to the nearest tenth, 13.4 centimeters. That's good now, because again, the radius of a great circle, which I just found, is the same as the radius of a sphere. So let's go into total area and volume now. Total area equals 4 pi times my radius, 13.4 squared. My total area, I have to plug this in. I want to leave this in terms of pi. So I started out estimating for pi, because there was no pi in the circumference here, but I'm going to leave pi in my answer for total area. Multiply that all out, I get my total area is 179, let's round to the nearest hundredth, 0.56 centimeters squared. Volume, again, 4 pi r cubed, so our radius again, right here, 13.4, cubed all over 3. Plugging this all in, and again, since I'm dealing with decimals, I can go ahead and divide. So I'm going to get my volume equals 3,208, again, round to the nearest hundredth, 0.14 pi. Talking about centimeters again, centimeters cubed. Moving on, let's try one more of these. This time is very similar. In this example, again, we have the area of a great circle this time. So the previous one we had the circumference. Here we have the area. So the area of a circle is pi r squared. Let's erase that. So again, area of a circle is pi r squared. So again, pi r squared this time equals 70.58. Again, since there's no pi in this area right here, we're going to go ahead and use 3.14 for pi. So I'm going to get my radius squared times 3.14 equals 70.58. Divide by 3.14, I get my radius squared equals 22.47, again rounding to the hundredth. I take the square root of 22.47, and I get 4.74 as my radius. Once again, this is the radius of the great circle, which if it's the radius of the great circle, it is also the radius of the sphere. So now I have the radius of the sphere, I can move forward with finding the total area and the volume. Total area equals 4 pi times the radius, 4.74 squared. 4.74, round this to the nearest hundredth as well, I'm going to get 4 pi times 22.47 22.47. 4 times 22.47, total area equals 89.87. Again, let's put pi in our answer here. This time we're talking about feet squared. Moving on to volume. 4 times pi times my radius, 4.74. Cubed this time, all over 3. So plugging this in, 4.74 cubed ends up being, I get 4 pi times 106.50, rounding to the nearest hundredth, all over 3. When I multiply 4 times 106.50, I get my volume equals 426 pi over 3, and actually 426 is divisible by 3, so my volume ends up being 126 pi. Moving on. These last two examples, we're still talking about a plane passing through a sphere, but just not at the center. This time, as you can see, a plane is going to pass 4 centimeters from the center of the sphere. So I'm going to do my best to draw this in. So think about a plane passing like that through the sphere. 4 centimeters from the center. Here's roughly where the center of the sphere is. So that distance right there is 4. It also says that the radius of the sphere is 7 centimeters. Again, a radius goes from the center to any point on the side. So there is 7 meters, there is 7 meters, there is 7 meters, and so on. The only place where it will be beneficial for us to draw the radius, though, is from the center up to the edge of the circle of intersection. I do that, there's my 7 centimeters, because now I know that I can form this forms a 90-degree angle. Again, we're going to move it from the center to the edge of the circle that's intersecting the sphere, because there forms a right angle. The missing, a right angle and a right triangle. The missing side of this right triangle is going to be the radius of the circle of intersection. As we all know, as we've done for a very long time now, we find the missing side of a right triangle with Pythagorean theorem. So here is my hypotenuse. I'm going to go 7 squared equals 4 squared plus my radius squared. Again, this is the radius of the circle of intersection, this right here. I'm trying to find the area of this circle. So I get 49 equals 16 plus r squared. Subtract 16, I get my radius squared equals 33. My radius is the square root of 33. That's so important that I find that missing side of the right triangle, which is also the radius of intersection, because to find the area of a circle, I need the radius. So now this is going to be the area of the circle, and this circle right here, I'll put the dashes through it in orange. That's the area that I'm looking for, is going to equal pi times the radius, which I just found, radical 33, squared. The square root of radical 33, the area of the circle, ends up being 33 pi, and we're talking about centimeters here, centimeters squared. So the area of this circle of intersection, this guy right here, not the whole sphere, not anything else but this circle, is 33 pi centimeters squared. One last example. This one time is talking about a plane passing 9 centimeters from the center of a sphere with a radius of 15 centimeters. So very similar. Here is my center of the sphere. Here is the circle that is passing through the sphere. The center of this circle is 9 centimeters from the center of the sphere. The radius of the sphere is 15 centimeters. Again, like on the last example, I can draw this radius anywhere. That's 15, and so on. This is 15 down here. But I'm looking for the area of this circle of intersection, so it is important to me to find that radius. So not only do I need the radius of that circle, I need to apply the radius of the sphere to the edge of that circle of intersection right there. Let's try that one again. That's not very straight. That's a little better. And we want to draw it there. Again, that's 15. because now once I attach the radius of the circle of intersection, I have a right triangle. Just like before, I can find the missing side of a right triangle with the Pythagorean theorem. I can go 15 squared equals 9 squared plus r squared. 15 squared is 225 equals 81 plus r squared. Subtract the 81, I get my radius squared equals 144. My radius of the circle of intersection is 12. Again, this radius is much different than the radius of the sphere. I'm looking for the area of this circle, so I'm going to take area of that circle is pi times the radius, which is 12, squared. 12 squared is 144, so the area of this circle, one last time, is 144 pi centimeters squared. That concludes the lesson. Make sure to watch the video tomorrow night, or actually watch the video Monday night for Tuesday's lesson.